Alright, let's dive straight into the Internet of Things. The core idea is pretty simple. Anything that can be connected will be connected. Think about it: your phone, your fridge, even your coffee maker. Eventually, they're all part of this massive network. So, what are we going to cover today? We'll start with the basics. What exactly is IoT? Then we'll explore why it's such a big deal, looking at the benefits it brings. We'll see where it's being used right now, and then tackle the challenges it throws up. After that, we'll look at what needs to be done to make IoT better, and finally, peek into the future trends and technologies shaping its path. And of course, we'll wrap up with some Q&A. Let's get started. Okay, so what is IoT? At its heart, it's a system of interconnected things, not just computers, but also machines, objects, even animals or people. These things get unique IDs, like digital fingerprints, and the magic happens when they can talk to each other over a network, without needing you or me to push a button. Think about it: a heart monitor implant in a person, a biochip tracking a farm animal, sensors in your car warning you about low tire pressure. Basically, any object that can get an IP address and send data counts. It's essentially a giant sensor network connecting billions of smart devices, people, systems, and apps to collect and share information. It's about making the world around us smarter and more connected. Let's dig a bit deeper into that definition. The concept is really about connecting anything that has an on-off switch to the internet, or even to other devices. We're talking cell phones, sure, but also your coffee maker, washing machine, headphones, lamps, wearables, the list goes on. Even parts of machines, like the jet engine of an airplane or the drill on an oil rig, can be connected. So, the IoT is this vast network of connected things, including people. The relationships here are key: people to people, people to things, and things to things. Interestingly, the smart TV is currently the most common consumer IoT device globally, with a significant chunk of households owning one. But don't sleep on other areas. The growth in other sectors of the IoT market is absolutely exploding. Now, why should we even care about all this? Why is IoT such a hot topic? Well, organizations across pretty much every industry are using it to become more efficient. They're using it to understand their customers better and deliver seriously enhanced customer service. It helps them make smarter decisions based on real-time data, and ultimately, it increases the value of their entire business. It's about leveraging data to optimize operations and create new opportunities. So, how does all this work together? We call it the IoT ecosystem. Imagine a web of smart devices, all enabled by the internet. These devices use tiny processors, sensors, and communication hardware to constantly collect data from their surroundings. They then send this data, acting on it as needed. The collected sensor data gets shared, usually by connecting to something called an IoT gateway or another edge device. From there, the data can either be sent off to the cloud for heavy analysis or processed right there locally, depending on the situation. It's a continuous flow of information enabling intelligence. Here's a visual breakdown of that ecosystem. You've got the user, that's you and me, interacting with apps. Then the IoT devices themselves, the physical gadgets collecting data. Data flows through the network, ensuring secure transmission. Security is paramount, protecting the whole system. Often, there's a gateway acting as a bridge between devices and the cloud, which stores and analyzes the massive amounts of data. Finally, applications allow users to interact with the data and control the devices. All these pieces work together seamlessly to make the IoT system tick. Let's look at some strategic trends shaping the future of IoT, according to Gartner. First up, artificial intelligence. Data is the fuel for IoT, and AI is the engine that turns that fuel into meaningful insights. Your ability to derive meaning from the data dictates your long-term success. Second, social, legal, and ethical IoT. This covers tricky stuff like who owns the data, potential biases in algorithms, privacy concerns, and compliance with regulations like GDPR. A successful IoT solution isn't just technically sound, it must be socially acceptable. Third, infonomics and data broking. This takes data monetization seriously, treating data as a strategic business asset. By 2023, buying and selling IoT data became a standard part of many systems. Continuing with Gartner's top trends, number 4 is the shift from intelligent edge to intelligent mesh. We're moving away from everything relying solely on the central cloud towards more distributed, edge-based architectures. Think of mesh networks where devices connect directly to each other. This makes systems more flexible, intelligent, and responsive, though it adds complexity. Fifth, IoT governance. As the IoT sprawls everywhere, we desperately need frameworks to manage how data is created, stored, used, and deleted. Rules are crucial. Sixth, sensor innovation. The sensor market is constantly evolving. New sensors are popping up, allowing us to detect a wider range of situations and events, giving us more data points to work with. Wrapping up Gartner's list, Trend 7 is trusted hardware and operating systems. By 2023, expect to see hardware and software combinations designed specifically to create more trustworthy and secure IoT systems. Security is baked in. Eighth, novel IoT user experiences. This is driven by 4 things: new sensors, new algorithms, new experience architectures, and context-aware, socially aware interactions. It's about making the IoT feel natural and intuitive. Ninth, silicon chip innovation. Expect new, specialized chips by 2023 that drastically reduce the power consumption of IoT devices, extending battery life. And 10th, new wireless networking technologies. IoT networking needs to balance range, power, cost, and speed. Look out for 5G, low Earth orbit satellites, and backscatter networks offering new possibilities. So, let's recap the benefits IoT offers to organizations. It's not just about fancy tech, it delivers tangible advantages. IoT enables you to monitor your entire business processes in real time. It helps improve the customer experience, making interactions smoother and more personalized. It saves time and money by automating tasks and optimizing resources. It enhances employee productivity by providing better tools and information. It allows you to integrate and adapt your business models quickly. It leads to better business decisions based on data, not guesswork. And, ultimately, it helps generate more revenue by opening up new services and efficiencies. Where does IoT come from? It builds upon several existing technologies. Think of the 4 pillars of IoT. You've got machine-to-machine communication, the foundation of automated systems. Then there's SCADA, supervisory control and data acquisition, used heavily in industrial control. RFID, radio frequency identification, for tracking items. And WSN, wireless sensor networks, for deploying sensors wirelessly. IoT essentially takes these established technologies and connects them together, creating a much broader, more integrated system. It's like taking different tools and realizing they can work together beautifully. Looking at the technology landscape around 2022, here were some key trends. IoT was becoming a cornerstone for sustainability efforts. The focus was shifting from purely cloud-based platforms to edge computing, processing data closer to the source. Industrial IoT projects were fundamentally changing manufacturing. Cloud-native applications were rising, built specifically for the cloud environment. Hyper-automation, combining AI and RPA, was transforming operations. AI was increasingly finding its way onto edge devices, making them smarter locally. Invisible AI adoption was happening quietly, embedding intelligence into everyday systems. Immersive reality, VR and AR, was entering the enterprise. 5G was getting ready for the IoT, promising faster speeds and lower latency. And finally, secure remote access to assets was becoming critically important, especially post-pandemic. What are the key technologies actually driving the development of IoT? Let's start with cloud computing. IoT generates massive amounts of real-time data. Think about millions of sensors constantly streaming information. You need somewhere huge to store this data and the processing power to analyze it. That's where cloud computing comes in. It provides the scalable storage and computational muscle needed for IoT to function effectively. Its efficiency and scalability make it a perfect partner for handling the data deluge of the IoT era. Another major driver is blockchain. Now, you might think blockchain is just for cryptocurrencies, but it's incredibly useful for IoT too. Combining IoT with blockchain ensures data integrity and authenticity. Think about supply chain logistics. IoT devices can track goods, assigning each product a unique digital ID. Blockchain can then create a tamper-proof, secure record of the product's history. Companies and customers can trust that the product is genuine and the information hasn't been altered. Integrating these two technologies gives a huge competitive edge. Sensors are absolutely fundamental. They are the eyes and ears of the IoT world. They are the key elements that allow IoT solutions to interact with the physical world. We use sensors for countless daily activities, like remotely locking your car. Advanced IoT sensors go far beyond that. They enable remote monitoring and control of various activities. Because they allow for such remote interaction, sensors are a cornerstone technology driving the development of IoT solutions. Modern problems often require modern solutions, and IoT software development companies are stepping up to provide these. And finally, artificial intelligence. We've touched on this, but it's worth emphasizing. IoT generates a flood of data. AI is the tool that helps businesses analyze this massive dataset and extract valuable insights. It helps turn raw data into actionable intelligence. Remember how IoT was once seen as a futuristic concept? During the global pandemic, we saw firsthand how IoT helped businesses across industries not only survive, but thrive. These technologies, cloud, blockchain, sensors, AI, aren't just driving IoT development, they're expanding its scope and pushing it towards greater heights. IoT is accelerating, and future advancements will be key to the next wave of digital transformation. So, how do you actually build a successful business model around IoT? It involves three key stages. First, develop the IoT product. This is about getting your product to market fast and building in the necessary connectivity features. Time to market is critical. Second, develop the business model. Here, you figure out your market position, define the value chain, and decide on your revenue streams. How will you make money? Third, commercialize the IoT product. This involves pricing your product, driving adoption, and measuring your success. It's a continuous cycle from idea to market impact. Let's break down those key business drivers for IoT development. One major driver is increasing productivity. How? By optimizing processes and costs. For example, connected machines can provide daily usage data or environmental readings, enabling predictive maintenance or optimized inventory management. Another driver is generating new revenue streams. This comes from creating new offers and business models. Think about new agricultural management models using connected sensors and scientific knowledge to continuously monitor crops and optimize production. Enhancing regulation compliance is another driver. Remote equipment monitoring can help meet regulatory requirements, like mandatory smart metering for electricity or gas. And finally, improving customer loyalty. Enriching customer relationships through IoT features like in-car connected devices for fleet tracking or premium concierge services can build stronger loyalty. This diagram shows how IoT fits into various industries and drives business outcomes. On the left, you see key technologies like virtual networks, big data, fast data, IoT, and cloud computing. These are applied across sectors like automotive, transport, industrial, retail, smart cities, and healthcare. In the middle, it highlights how these technologies enable remote and autonomous operations, advanced analytics, and asset integrity management. On the right, the business impacts are clear: increased efficiency, safety, and environmental friendliness, predictive maintenance boosting exploration and production rates, and optimized asset allocation improving revenue per asset. Notice the distinction between big data and fast data. Big data is the massive volume of information generated. Fast data is the real-time, streaming data from IoT and event-driven apps that allows for rapid, actionable business decisions. In fields like payments, analyzing fast data quickly is absolutely crucial for the bottom line. Where do we actually see IoT in action? Here's a snapshot of consumer and enterprise IoT applications. Think smart cities managing traffic and utilities, smart cars with connected features, wearable devices tracking health, smart homes controlling appliances, smart appliances like refrigerators ordering groceries, smart health monitoring devices, smart agriculture optimizing crop yields, and smart TVs streaming content. This is just a glimpse into the vast landscape of IoT applications impacting our daily lives and businesses. Imagine the future powered by IoT, the smart world of the future. This image gives a taste of the possibilities. We're talking about monitoring air quality, predicting forest fires, enhancing wine quality through sensors, caring for animal offspring, monitoring athlete health, checking structural health of buildings, detecting water quality, optimizing garbage collection, smart parking, efficient golf course irrigation, vehicle diagnostics, locating lost items, detecting water leaks, monitoring traffic congestion, measuring electromagnetic radiation, detecting smartphones, smart roads and lighting, smart shopping experiences, mapping urban noise, smart parking again, studying water quality, and monitoring cargo conditions during transport. It's a vision of a highly interconnected, data-driven world aiming for efficiency and improved quality of life. Let's look at some specific examples of consumer IoT products and services. There's the helmet concussion sensor, detecting dangerous impacts in sports. Medical alert watches for seniors or anyone needing emergency assistance. Smart fitness clothing and running shoes that track your workout. Then there's the one-button product purchase concept, like Amazon Dash buttons. Need Tide laundry powder? Just press the button, and Amazon reorders it for you instantly. No website login, no payment details needed. Garden sensors to monitor soil moisture and weather. And of course, smart televisions that stream content and connect to other devices. These are just a few examples of how IoT is making its way into our homes. Take this helmet concussion sensor, the shock box. It's a wireless head impact sensor designed for sports like hockey. It fits onto your helmet and uses Bluetooth to connect to your smartphone. If an impact exceeds a certain threshold, it sends an alert directly to your phone. It has a long range, good battery life, and an app to track impact history. It's a practical application of IoT aimed at improving player safety. While this specific model might be unavailable now, the concept is very real and addresses a serious need. Remember Amazon Dash buttons? This was Amazon's attempt at that one-click ordering concept. You could buy physical buttons linked to specific products you frequently ordered. Need more diapers? Press the Pampers button. Out of paper towels? Hit the Cliff Bar button. You could find these buttons on the Amazon homepage, manage them, or even add new ones from product pages. You could even use them with your Echo Show or Samsung Family Hub smart fridge. It was a simple, physical interface to the vast online marketplace. While the physical buttons themselves aren't widely available anymore, the idea of seamless reordering persists in other forms. Here's another consumer example, the Kinsa thermometer. This isn't just a thermometer, it's connected. It measures your temperature and connects to your phone via Bluetooth. The app can track readings over time, compare them to typical values, and even suggest actions based on symptoms and age. For parents, it offers a way to monitor children's health and potentially know when to seek medical advice. It turns a simple health measurement into a data point that can be analyzed and contextualized. Let's talk about the connected car. This is a huge area. Cars equipped with internet connections and specialized software allow you to stream music, look up movie times, get alerts about traffic and weather, and even use driving assistance services like self-parking. The market is booming. By 2020, projections showed over 220 million connected cars globally, with a significant portion having built-in connectivity. Revenue is expected to grow from hardware sales to software subscriptions and services. Interestingly, while many people knew about streaming music in cars, fewer realized it was already available. And the future? Autonomous vehicles are coming, with millions projected on the road soon. How about smart farming? Using IoT to revolutionize agriculture. Imagine a system that monitors crop fields using sensors for light, humidity, temperature, soil moisture, and more. It can automatically control irrigation systems. Farmers can check field conditions from anywhere in the world. Compared to traditional methods, this is incredibly efficient. Plus, it's great for the environment, leading to better water usage and optimized application of fertilizers and pesticides. Ultimately, IoT in farming helps reduce waste and boost productivity. Specific applications include precision farming, agricultural drones, livestock monitoring, and smart greenhouses. Now, let's zoom in on industrial IoT, or IIoT. This focuses on using cyber-physical systems to monitor physical factory processes and make automated decisions based on data. Think of factories becoming smarter. While the physical systems themselves become intelligent through IoT, the real-time communication and collaboration between machines and humans happens via the wireless web. IoT brings the powerful concept that a connected factory leads to a smart factory. So, how does IoT work in manufacturing? First, it enables digital or connected factories. IoT-enabled machinery can transmit operational data to partners like original equipment manufacturers (OEMs) and to field engineers for remote diagnostics. Second, facility management gets a boost. IoT sensors on equipment can trigger condition-based maintenance alerts, fixing problems before they cause downtime. Third, production flow monitoring becomes possible. IoT can track production lines from raw material processing all the way to final product packaging. Fourth, inventory management improves. IoT applications allow monitoring of inventory levels and events across the entire supply chain. Continuing with IoT in manufacturing. Fifth, plant safety and security improve. Combining IoT data with big data analytics can enhance worker safety and overall plant security. Sixth, quality control gets sharper. IoT sensors collect aggregate product data and third-party data throughout the product lifecycle, helping identify defects early. Seventh, packaging optimization occurs. By embedding sensors in products or packaging, manufacturers gain insights into how customers use and handle products. Eighth, logistics and supply chain optimization is achieved. IoT provides real-time visibility of materials, equipment, and products moving through the supply chain, improving efficiency and responsiveness. What technologies are actually involved in building IoT systems? IoT primarily relies on standard protocols and networking technologies. However, some key enabling technologies and protocols stand out. These include RFID, NFC, low-energy Bluetooth, various low-energy wireless protocols, LTE Advanced, and Wi-Fi-Direct. Each has its strengths and is suited for different types of IoT applications. Let's look at NFC and RFID. Both offer simple, low-energy, and versatile options for things like identity tokens, access control, connection setup, and payments. RFID uses radio waves to identify and track tags attached to objects. NFC is a set of communication protocols for electronic devices, typically involving a mobile device and another standard device, like a payment terminal or a smart poster. They're great for short-range, quick interactions. Low-energy Bluetooth is a big one for IoT. It supports the low-power, long-use requirement of many IoT devices while leveraging a widely supported standard. It's great for connecting devices like wearables and sensors. Low-energy wireless is another category that focuses on minimizing power consumption, especially for the communication link. While sensors might sleep for long periods, the wireless connection needs to stay listening. Low-energy wireless reduces this consumption significantly, extending the battery life of the device. Radio protocols like Zigbee, Z-Wave, and Thread are designed for creating low-power, private area networks. They offer high throughput compared to some other low-power options, making them suitable for robust local device networks without high costs. LTE Advanced, or LTE-A, is a significant upgrade to LTE technology. It improves coverage, reduces latency, and increases throughput. This gives IoT tremendous power, especially for applications like vehicle-to-everything communication, UAVs, and similar scenarios requiring reliable, wide-area connectivity. Wi-Fi Direct eliminates the need for a traditional Wi-Fi router or access point. It allows devices to connect directly to each other in a peer-to-peer fashion, achieving the speed of Wi-Fi but with potentially lower latency. By removing the central access point bottleneck, it can improve network performance without compromising speed or data throughput. It's useful for direct sharing and control between devices. This table compares some key wireless technologies: Bluetooth, UWB, Zigbee, and Wi-Fi. You can see differences in standards, frequency ranges, maximum data rates, power levels, channel bandwidths, modulation types, and security features. For example, Bluetooth operates at 2.4 GHz, while Wi-Fi uses both 2.4 and 5 GHz bands. Wi-Fi generally offers higher throughput but consumes more power than Zigbee or Bluetooth. Understanding these differences is crucial for selecting the right technology for a specific IoT application. Here's another comparison table, focusing on technologies relevant to IoT: Bluetooth Low Energy, Wi-Fi, Z-Wave, IEEE 800 and 2.15. 4. Which covers Zigbee and Thread, LTE-M, NB-IoT, Sigfox, and LoRaWAN. It compares them across range, throughput, power consumption, ongoing cost, module cost, topology, and shipment volumes. Notice how Bluetooth Low Energy offers low power and moderate range, while Wi-Fi offers high throughput but higher power. Technologies like LTE-M and NB-IoT are cellular options for low-power, wide-area networks. LoRaWAN is known for very long range and low power. Choosing the right one depends entirely on the application's needs. This table specifically compares two cellular IoT technologies, LTE-M and NB-IoT. Both are designed for low-power, wide-area networks. LTE-M offers a wider bandwidth, supports voice and data, and has better mobility. NB-IoT uses a narrower bandwidth, focuses on data only, and has excellent coverage and deep indoor penetration. LTE-M modules are smaller, suitable for wearables, while NB-IoT modules are larger. LTE-M offers better throughput, but NB-IoT excels in coverage and cost-effectiveness for simple data transmission. The choice depends on whether you need voice, mobility, or maximum coverage and lowest cost. Okay, let's talk about the challenges. IoT isn't all sunshine and rainbows. A big one is security, privacy, and data sharing issues. Because IoT devices are often connected, a single vulnerability can compromise the entire system. If manufacturers don't update devices regularly, they remain exposed to cybercriminals. Privacy is another huge concern. Companies could potentially misuse personal data collected by your devices. For industrial IoT, or IIoT, the challenges include I. Data security, same as consumer IoT, but potentially with more severe consequences. 2. Reliability and stability of sensors in harsh industrial environments. 3. Connectivity and maintenance of potentially thousands of devices in a complex setup. 4. Blending legacy systems with new IoT technologies, which can be tricky. What about edge computing? Sometimes called enhanced data rates for GSM evolution, edge, or enhanced GPRS, EGPRS. Edge computing is a computing paradigm where data processing happens closer to the source of the data, at or near the user. Instead of sending all data back to a central cloud, edge computing processes it locally, on the device or a nearby server. This enables faster processing, handles larger volumes of data locally, and allows for quicker, more responsive actions in real time. It's about bringing computation and data storage closer to the edge of the network. This diagram nicely illustrates the difference between cloud computing and edge computing. On the left, traditional cloud computing. Data from devices like cars, cameras, traffic lights, phones travels to the central cloud for processing. On the right, edge computing. Data is processed locally, often at an edge server located near the devices. This reduces latency, conserves bandwidth, and enables real-time responses, which is crucial for many IoT applications. Let's delve deeper into IoT security issues. First, public perception. If people don't trust IoT devices, they won't adopt them. Deloitte found over half of users were worried about smart home device vulnerabilities. Second, vulnerability to hacking. Researchers have successfully hacked real market devices. For example, a team found numerous security holes in Samsung's SmartThings platform, and the methods weren't overly complex. This means real hackers could likely do the same. Third, are companies ready? A survey by AT&T found 85% of enterprises were deploying or planning to deploy IoT devices. But only 10% felt confident they could secure them against hackers. That's a massive gap. Fourth, true security. As Jason Porter from AT&T pointed out, securing IoT isn't just about the device itself. It requires building security into the software applications and the network connections that link everything together. It's a holistic challenge. Now, let's look at IoT privacy issues. First, too much data. The sheer volume of data generated by IoT devices is staggering. The FTC reported that fewer than 10 households could generate 150 million data points daily. More data points mean more potential entry points for hackers and vulnerabilities. Second, unwanted public profile. When you agree to terms of service, you often give up data rights. Companies can use this data for decisions like employment or insurance rates. Your driving habits from a connected car could affect your insurance premium, or your fitness tracker data could influence health insurance. Third, eavesdropping. Manufacturers or hackers could potentially use a connected device to virtually invade your home. German researchers demonstrated this by intercepting unencrypted data from a smart meter to figure out what TV show someone was watching. Fourth, consumer confidence. All these issues, security risks, data misuse, privacy invasions, can erode consumer confidence and hinder the widespread adoption of IoT, preventing it from reaching its full potential. Breaking down the security and privacy concerns further, we see specific areas needing attention. Under data confidentiality, insufficient authentication or authorization, insecure interfaces, web, mobile, cloud, lack of transport encryption, confidentiality preserving techniques, and robust access control. Under privacy, privacy risk management, designing systems with privacy in mind, privacy by design, adhering to data protection laws, and addressing traceability, profiling, and unlawful data processing. Under trust, secure identity management, secure software and firmware, ensuring service continuity and availability, defending against malicious attacks, and maintaining user control and decision-making capabilities. This diagram visually summarizes the relationship between security issues and privacy concerns. At the center, we have security issues and privacy concerns. From there, arrows point to core security attributes: confidentiality, integrity, and authentication. These are the pillars of security. Other arrows point to specific privacy-related aspects: identity, location, trajectory, and report query. These highlight the types of sensitive information that could be compromised, emphasizing the intertwined nature of security and privacy in the IoT world. This table outlines 5 key security requirements for IoT systems. First, confidentiality. Information transmitted between devices must be protected from attackers. Second, authorization. Device privileges should be restricted to only what they need for specific tasks. Third, authenticity. Access to the system and sensitive information should only be allowed for legitimate users. Fourth, integrity. Ensuring data accuracy and completeness, preventing tampering. Fifth, availability. Ensuring the security service and the system itself are continuously available to avoid operational disruptions. These are the fundamental security pillars for any IoT deployment. So, what needs to be done to address these challenges? There's a whole list of potential actions. Consumer education is crucial. People need to understand the risks. Product reviews and comparisons can help users make informed choices. Vulnerability disclosure and vulnerability markets incentivize finding and fixing security flaws. Self-certification and voluntary codes of practice can encourage better security practices. Trust marks and labels, like OTA's IoT Trust Framework, can help identify trustworthy products. Government initiatives and mandated security requirements can enforce minimum standards. Mandated certification programs can ensure compliance. Liability reform might be needed to clarify responsibilities. And then there's the controversial option, no intervention. But generally, a combination of education, industry self-regulation, and potentially government oversight seems necessary. Let's briefly revisit the value chain. This diagram shows the traditional M2M, machine-to-machine, value chain. It starts with inputs, moves through production/manufacturing, processing, and packaging, and ends with distribution and marketing. This represents the flow of physical goods and traditional business processes. Now, how does IoT transform this value chain? This diagram shows the shift from M2M to IoT. On the left, you still have the physical production flow, but on the right, you see the emergence of the information market. Data flows from devices and sensors, open data sources, operational support systems, OSS, business support systems, BSS, and corporate databases. This data is combined, processed, and turned into information components, ultimately forming an information product. The value chain now includes generating and monetizing data itself. Here's the full IoT value chain. It starts with hardware, the devices, sensors, and communication hardware like SIM cards and chipsets. Then comes connectivity, the various network technologies like cellular, LoRa, Wi-Fi, Bluetooth, satellite, fiber, etc. that enable the devices to communicate. Finally, there's the application layer, where data is collected, analyzed, and used through software development, application enablement, device management, data analytics, billing, support services, and system integration. It's a complete ecosystem from hardware to software to services. Given the complexity and scale of IoT, governance is essential. An IoT governance framework needs to ensure data integrity and security for all information shared across the enterprise network. It must also maintain a trusted source of information across all layers of the IoT architecture, from the sensors up to the applications. Without good governance, the risks we discussed earlier multiply. Why is governance so critical? As IoT usage grows, the network of devices becomes enormous and complex. Statista estimated around 13.1 billion IoT devices in operation. An IoT governance model helps address data security, privacy, legal, ethical, and public relations concerns. It establishes policies, procedures, and practices for designing, building, deploying, and managing IoT systems. Crucially, it ensures compliance with data security and privacy laws, which vary globally. How data is collected, stored, managed, used, and discarded must align with regulations like GDPR in the EU. Failing to protect sensitive personal identifiable information, PII, can lead to hefty fines. This diagram proposes a comprehensive IoT governance model. It considers stakeholders, business needs, risk management. It covers the design phase, including infrastructure, sensors, actuators, data handling, fog computing, security, and communication. Implementation involves devices, applications, analytics, integration, and testing. Operations focus on management, monitoring, innovation, and scalability. And the governance mechanisms themselves include frameworks, principles, policies, standards, skills, culture, tools, dashboards, and metrics for visibility. It's a holistic approach to managing IoT effectively. What does the future hold for IoT? The numbers are impressive. Bain company projected annual IoT revenue exceeding $450 billion by 2020. McKinsey estimated an $11.1 trillion impact by 2025. IHS Markit predicted 125 billion connected devices by 2030. Gartner assessed 20.8 billion connected things by 2020, with $3.7 trillion spent on IoT devices and services in 2021. By 2023, the average CIO would be responsible for over 3 times as many endpoints as before. Gartner forecasted $3.11 billion in worldwide IoT security spending by 2021, driven by regulation. We expect significant improvements in device security, driven by manufacturers and user demand. Analytics from connected devices will be used extensively for process optimization. And by 2020, Business Insider predicted 75% of new cars would have built-in IoT connectivity. If you're interested in building your own IoT solutions, there are many hardware platforms and prototyping kits available. Raspberry Pi is a popular single-board computer running Linux. Arduino is well known for its microcontrollers, open-source tools, and kits. Picom offers boards like WiFi and LoPi with flexible connectivity options. Particle provides hardware designed to work with their software platform. Sodak focuses on durable, solar-powered hardware for B2B deployments. Adafruit and SparkFun offer a wide range of development boards and components. Espressif specializes in highly integrated microcontrollers popular among developers. These platforms provide the building blocks for creating and testing IoT devices. Finally, let's see how IoT is used across various industries. This diagram shows applications in agriculture, industrial, automotive, healthcare, military, environmental, and retail. In agriculture, offspring care, crop management, soil analysis. Industrial, machine-to-machine communication, quality control. Automotive, vehicle diagnostics, traffic flow optimization, smart parking. Healthcare, patient care optimization, wearables, quality data reporting. Military, situational awareness, threat analysis. Environmental, fire detection, species tracking, weather prediction. Retail, anti-theft, inventory control, targeted marketing. The possibilities are vast, and IoT is transforming nearly every sector. That brings us to the end of the presentation. Thank you for listening.